but I like it so I enjoy it so much when you actually do the slide. Can you please be a sweetheart and do the slide?
Well, I think that's probably an excuse. Either you lost my email or you just can't find it.
No, I can. If it's important, I actually have the email which says sort of here's the problem is it's sometimes difficult for me to uh, know some of the things in the slide what you're talking about. But let me.
Well, okay, if I do the slide, can you admit people? Because it's really hard to do both.
Sure, sure.
Okay, all right. Because it's really not rocket science. All you have to
Of
do is
course
just
it's not. Of
read.
course it's not. And I
Okay.
actually have no idea who that guy, who the lookalike guy is.
Oh, you don't? Okay, okay.
No.
All right. What controversial? What?
Period. Western content censored by state internet. Yes,
Okay,
that's
so
the
I think we are recording and I will share my screen. Okay, you want to say hi? Okay, we have a special guest. This is not my slide today. Do you want to say
Hello.
hi? She's gonna be a future Python guru.
That
Um,
sounds like a threat.
all right. Okay, slides.
Yes.
Music. Okay,
No.
sounds familiar.
We don't hear
Um,
anything.
so next week is really exciting because we have our special guest number two. I purposely did not get TJ so that, there's no risk of this guy getting proposition two. I mean, although he could get his own proposal, this guy is like supposedly a SIP legend. And then he actually played a very instrumental role in the founding of SIP. And then just for the hint, it is not Chris, it is not Maron, it is not TJ. And this guy has won just about every single teaching award Stanford has given. And so if you want to find out who it is, okay, you should come next week. And then this guy has agreed. Well, I mean, I use the word guy loosely. Okay, this person has agreed to talk about visualization using Python, NumPy library, and Pandas library. And there's actually no like homework this week, but I just included some references if you wanted to get a head start on learning how to use these tools. And then, Alex, you're definitely welcome to come next week if you want to kind of learn. Okay.
I probably will come.
But in case, you're not here, okay, Alex will return at the end of the month on the 23rd and the 30th. And then I think we'll be wrapping up sometime at the end of August. And so we're definitely going into the home stretch with just 2 to 3 sessions left. And so if you have any lingering questions, you want to know about Python, want to know about like board games, meaning of life, and you want to just pick Alex's brain, this is your chance to do so now or forever. Hold your peace. And then the YouTube videos have been anonymized and uploaded to YouTube. The Zoom link never changes. And then, since Alex doesn't really want to bet with me anymore, okay, I thought, we would show, does anyone know who these two people are? And then do you think they actually look alike? If you do, feel free to shout them out or type it in the chat to
I
who
have no idea who they are, but they do
are.
look alike. Almost
Anybody wants to like, yes, yes. Okay. So
that Kiara wrote that in the
so
chat.
some
I
of
have
you
no idea
recognize
what that
the
means.
guy with the medal is the US pommel horse guy. He won
What,
like a bronze
what's
medal
a
at
comic
the
horse?
Olympics this past week and helped the US team win the bronze in the men's gymnastics, which hasn't happened in like over a decade. But who's this guy on the left that kind of looks like the pommel horse guy on the right? Identical twin? No, he's not an identical twin. They're completely unrelated. They
What's
are
a
completely
horse?
unrelated.
Doppelganger man?
Not doppelganger man.
It's a reasonable explanation.
Okay. So any guesses as to the person on the left? Okay. Probably not. So I'll just tell you.
The
The guy
only
on
guess
the
I see
left
is like
is the
actually
like
Cameron.
famous
Is this
Cameron.
Cameron?
Yes. The guy on the left is Cameron. I mean, I thought they actually looked alike, and then when I saw the pommel horse guy, I was like, oh, that guy looks like Cameron. But I haven't like actually told Cameron about this yet. So, anyways, if you come next week, I have more like separated at birth lookalikes I will show. Okay. That's about it. Alex. Alex, are
Yes.
you there?
Yes, I am.
Can you hear me?
Yes.
Okay. So basically, as I had mentioned, okay, I've been getting some like emails about like plans for life after code in place. Okay. For me, I'm actually returning to my normal life. Um, and then I can't really speak for you, so I will leave you to like comment as to what life after SIP is gonna be like for you. Okay. Um, but yeah, that's all I have to say.
Okay. Thank you. Richard, thank you for enlightening me on what a pommel horse is. I have not heard the term. I'm obviously not too much into the Olympics, but now at least I understand what the thing is. About life after code in place, I will, since in September, I will renew my regular teaching. I will probably do this until then, but after that, yeah, I'm planning to take a rest as well. I mean, this like code is in place has been with us for how long? Like April, May, June, July, August, 5 months is like okay, because otherwise we'll probably just go into code in place 2025. So yeah, today we are going to talk about a couple of things. We're going to talk about tuples, and we're going to talk about sorting. And I am not sure why these two things were together in Stanford's curriculum, because they are not connected in any way, but probably because there is actually not that much to talk about in terms of tuples. Sorting was sort of an additional topic to add to that, because when I talk about tuples, people usually already know what lists are. And if you want to talk about tuples, you say a tuple is a list that you cannot change. And basically, that's the gist of it. The difference is that lists are mutable and tuples are immutable. And all the rest is very similar in the sense that if you have, they even have similar methods. Uh, Tuples have the same methods as lists if it's a method that does not change the contents of the tuple. But otherwise, tuples do not have the methods that change the contents of a tuple. So for instance, I don't know, if you take, I'm trying to remember methods and failing miserably. If you take, for instance, the append method does not exist for tuples because it changes the tuple, it adds something. Or for instance, the pop method or the remove method does not exist for tuples because it changes the tuple. would change the tuple, but we can't. But for instance, if you take the count method or the index method, they exist for tuples as well because they do not mutate the tuple in any way. They just get information from the tuple. So there are some differences. Let me maybe share my screen and share my pie chart. Do you see my pie chart right now? I will take that as a yes. So one of the things that you have to bear in mind when you talk about tuples as opposed to lists, we remember that you want to do a list, you do it in square brackets. If you want to do a tuple, you do it in regular parentheses. That's the syntactic difference between lists and tuples. But one of the things that is different for tuples, if you want to create a list with only one element, you can do it easily. Like simple list would be like this. But if you want to create a symbol with only one element, you cannot do it like this. The reason for that is if we print what we think is a simple tuple, in reality will turn out to be a regular integer, because this mathematically is the same as simply writing 1, because anything in parentheses mathematically is the same as it without parentheses. So if you want to create a tuple with only one value, you actually have to add a comma without a second value. And in this case, you'll see that this is a tuple with one value. So this is something you need to bear in mind. If for some reason, for some weird reason, you want to have a tuple with only one value. We had a bunch of exercises or assignments which deal mostly not with tuples, but they actually deal with sorting. Because like I said, the topic of tuples is not very big, and like doing assignments with tuples after lists is kind of redundant. But if you have any questions on tuples that you want to ask, please shoot, ask away, and I'll answer them. Boom, 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 boom. I'm looking through the chat. Of course, it's about the dog. Obviously, it's not about tuples. It's about dogs. It's always about animals and cute children. It's never about programming, and that's okay. I don't mind. So let's talk about the more interesting thing. Let's talk about sorting. Because sorting is an algorithm which is used very commonly in programming, you always have to sort things in programs. And there are built-in sorting functions and methods in Python, and the one that is given in the materials is a function which is called sorted, like this. But this is not the only thing you can use in Python to sort something, because besides the sorted function, you also have a sort list method. And this is something which is, I believe, is not touched upon in the materials. I don't know why. Are sorting algorithms used in real life? Abhinav, when you say sorting algorithms, do you mean the different types of sorting algorithms or sorting in general? Like, are you asking whether sorting as an algorithm? Oh, okay. Like, you mean like different sorting algorithms. There are certain algorithms which are never used because they can be used for educational purposes, but not in real life. For instance, if you've ever heard of bubble sort, it's an algorithm which is often taught as the first sorting algorithm, but it's a very bad algorithm because it doesn't sort optimally. Its speed is very low. The complexity of the algorithm is high. So in Python, the functions that are used in Python for sorting use a combination of, it's called Tim sort, I believe, and Tim is the name of the person who came up with the algorithm, and it's actually a combination of two algorithms. And I'm not gonna go into detail about it because most people would just have eyes that are glazed over. So there are some situations in which you would use different algorithms, but mostly you would be okay with just using the built-in ones. So let's get back to sorting with an example. So for instance, let's say, let me create several data structures. So I'll have, for instance, a list. Well, let me just call it like numbers. It's going to be a list of mixed up numbers like 7 minus 4, 0, 13 minus 42, 17, 66, 9, 101, minus 13, and for instance, another 17. Then I will create a tuple. Let this be numbers list. I'll do a numbers tuple, which will be the same only in parentheses. I will create a dictionary, numbers dict, which will look something like this. For instance, I'll do like 1, then I do 7, then I will do, I don't know, whatever. It doesn't really matter what the keys and values are, like minus 3, like negative, etc., etc. So I'm creating different data structures that we know. We haven't discussed sets, so I'm not going to do a set. But this will be important to demonstrate the difference between the sorted function and the sort list method. So let's start with this. Let's go through the sorted function again, since it's been introduced in the materials for today's meeting. So the sorted function, what does it do? The sorted function takes in any sequence as a parameter. It turns the sequence into a new list, and this is important. It turns it into a new list, so it's going to be a different variable, a different yeah. So then what it does, it sorts the new list, and this is important as well, it returns the sorted list, the new sorted list. The original sequence remains. So to take a look at an example, for instance, let's take the list that we have and sort it using numbers list. Let's say I will save this into a new. First, let's do the following. First, let me simply print numbers list after that. If I run this program, you will see that the list that is printed has not been changed in any way. So I kind of sorted it, then I print it, but there is no change. The reason for this is that the new list that I generated was not saved anywhere. So I would actually have to do like new list equals the result of this function. And then if I print the new list, you will see that now it's a sorted list. So it's very important to save the result of your work into some variable. You could have saved it into the same variable. and then the old one would have been discarded and the new one would have taken its place. That also works. But by default, the list that you're getting is a different one. So here, for instance, I could print the old one and the new one, and I will see that the old one did not change. So here's the old one, and here is the new one, which is sorted. I can do the same with other types of data. So for instance, let's say I want to sort the numbers dictionary. And now my question to you is, it's still going to be a list. Remember, the result is always a list. Can someone take a guess what the result of this sort would be? Any guesses? If I print new list 2, what would the list look like?
It would be a tuple.
It would not be a tuple, because remember,
A tuple?
it returns a list. The sorted function always returns a list.
It would be a list. It would be like a 2D list.
No, it would actually be a 1D list. And I can see, I see Abhinav saying keys, key order, list of keys, only keys. Yes, because when we iterate over a dictionary, we only iterate over keys. So the sorted function would also iterate over keys, and it will sort those keys as if they were like regular elements. So if we print it right now, you would get a list of 4 keys, -3, 1, 4, and 7. So it would ignore the values completely. And once again, the result is always a list. So it's not going to be a dictionary, it's not going to be a tuple, it's always a list. Tuple is data type where order of elements matters. Yes, tuples are ordered. It will be not a tuple after sorting. I mean, I don't think that those two things are interconnected. I mean, it could have been a tuple, but the function returns a list. So that's the way the function works. Please explain, is it possible to turn dict into a tuple? Yes, it is possible to turn dict into a tuple. So for instance, to show you, we can use the tuple function on our dictionary. And if I print the result, we will get a tuple of the keys in the dictionary. But you have to realize, Svetlana, when we're turning a dictionary into a tuple, we are going to lose all the values. We will just keep the keys. So as you can see, I get the keys in the same order that they're in the dictionary, but the values are gone. Mika, I see your question about string sorting. I will gladly talk about it. And remind me if I forget about it. Give me a shout out. I'll talk about it. So it's ascending order if we have to sort. Yes, by default, the function, I will add this here in ascending order. By default, if we want to do it in descending order, we have to add a special named parameter, which is called reverse. If we go reverse equals true, then you will see that the values from the dictionary are sorted in descending order. Are sorted in descending order. Sorts. What if the keys are numbers and letters? Okay, this is a very valid question. Let's try and see what would happen if, for instance, we have a dictionary with mixed data types for keys. So let's say we'll call it SumDict, and we will have like A1, we will have 1A, we will have true 17, I don't know. I'm just coming up with this on the go. Like 314 will be left. It doesn't matter. What will happen if we try to sort this specific dictionary? Let's take a look. If I do sorted sum dict and I launch this, you will see that we will get an error because we are trying to compare instances of integers and strings. So if you have data types that you are unable to compare to one another, like numbers and letters or numbers and strings, you would get an error because under the hood, the sorted function uses regular mathematics to understand, which number is higher or which number is lower. So in this specific situation, we will get an error. And I will write this here. Like this will result in an error. What does it mean when they say dictionaries are also ordered in Python? Before, I think, Python 3.6, dictionaries in Python were unordered. That means that there wasn't an inherent order to the ways that the key value pairs were stored in a dictionary, and you would never know in which order, for instance, they would be printed if you print the entire dictionary. I think starting with 3.6, maybe 3.7, I don't remember the exact version of Python, they sort of became ordered in the sense that inside the dictionary, the key value pairs appear in the same order that they were added to the dictionary. But it's not ordered in the sense that a list is ordered, because lists have indices 0, 1, 2, 3, 4, 5. Dictionaries do not have indices, so there is no such thing as a first value or key value pair or the second key value pair, etc. But they are stored in the same order that they are added to the dictionary. I hope that answers the question, Abhinav. So Svetlana, you're saying, so if we want to change order of things in our tuple, we can turn it into a list so it becomes mutable and work on it. Yes, you could certainly do that. You can always take a tuple, change a tuple into a list, sort the list, and then turn it back into a tuple. That would work. The only thing you have to realize that the new tuple that you get, it's actually going to be a new tuple. It's not the same tuple that you had before, and you would have to save it, for instance, into the same variable if you want it to, like, the change tuple to remain in the same variable. So it cannot obviously change the tuple in place. It has to store it in a new place in memory and in a new variable, another variable. If we were to sort, Leah, I'm reading your question. If we were to sort with dictionary values, key equals dictionary. Yes. If you want to sort by the value, you could actually do it. So, for instance, let's do this. Where do we have here? Sorted, and let's add a key. So the key is the criterion by which you want to sort. And we could say we want to sort by values instead of sorting by keys. I think it would, no, not like this. Unbound method. Okay, so, yeah, I think should it be like this, maybe. Let me check. Doesn't apply to an int object. Maybe not exactly like this. Maybe you would have to. Let's come back to this a bit later, because when we talk about keys, when we talk about using functions and the lambda functions in order to sort according to different criterion, we'll get back to this, because I don't remember how you would actually use a method to do this, and at the moment I'm really not sure whether that's possible. Let's come back to this. So the keys are integers, they stay integer in sorted lists. Susanna, yes, that's exactly how it happens. how did 1 come before 7 in reverse? Where was that? We don't have 1 before 7. We have 7 for 1 minus 3. This one is not reversed. The one that we have here, we just simply turned the dictionary into tuple. This one is not reversed. This one is the reversed one. Yeah, it's the same one. So this is the way that the sorted function works. And once again, the reason why it's a function, because it can work with different data types, so any sequence would work. You could actually pass a string in. So for instance, if I do something like string equals like Alexander, and then I do sorted on this string and print it, does anyone care to venture a guess what would the result of this sorting be? What would I get if I print the result of this function call?
Would it just be Alexander in alphabetical order?
What data type would it be?
What data type? Probably still probably still a list of strings.
It would be a list of strings, and the strings would be what?
What do you mean the strings would be what?
Exactly, yes. Richard is saying it would be characters or letters. Characters is more correct answer, because letters are not the only things that we would have. So if, for instance, I type in my name and surname and an exclamation mark, the exclamation mark and the space symbol would also be sorted. So we would actually get a list of all the characters which are present in my string, sorted by ASCII value. So you would see that the space and the exclamation mark would go in front because they have a lower ASCII value in the ASCII table. A space is, I think, 32. Exclamation mark, I don't remember. Then you have the capital letters, which have a lower ASCII number than the small letters, because they go first in the table. So we have my A and B, the capital ones. And then you have all the small letters alphabetically listed, because in the ASCII table they do go in alphabetic order. And Mika, they would be alphabetical, because that's how sorting works for strings. So this is a good place to talk about Python sorting strings instead of numbers, because with numbers, ascending and descending order is quite obvious. If you have ascending, you first have small numbers, then large numbers. With descending, is the other way around. When we talk about sorting strings, the strings are sorted according to their ASCII number, ASCII code, whatever you call it. So in our case, as you can see, first it's like smaller ones, then the bigger codes, and then you go in alphabetical order. If you would have digits in here, for instance, if I put 1, 2, 3, you will see that the digits will be somewhere between here and here, because in the ASCII table, digits go before letters. So there you go. You have 1, 2, 3, and only then you have the letters. If I were to put some Cyrillic letters in here, so this is my name in Cyrillic characters, you would actually see that the Cyrillic characters go after the Latin characters, because this is like basic ASCII, like the first 128 characters. And this is all stored in Unicode, and Unicode characters have much larger ASCII numbers. So for instance, these are somewhere in the, I don't know, 17, 80, 90, 100 range, and these are in the 1000 range, the numbers for these characters, so they would go later. So I see a question, are there any fun magic methods to play with tuples while accessing data by indices and tuples, just like in list? Well, I mean, tuples can be accessed through indices, much like lists. So the question is, what do you mean by playing with tuples? I mean, anything that you can do with a list that does not change the list, you could do with a tuple. Tuples do not have anything extra as opposed to lists. And I mean, some people ask, why do you need tuples when you have lists? Because tuples seem to be a very limited version of a list. And that is true. The reason to have tuples is that since Python knows that they're not going to be changed during the duration of the program, it's a lot easier to store tuples in memory and access tuples when you work with them, because they are stored differently in memory, since Python knows exactly how much memory a tuple needs to be stored right at the moment when the tuple is created, as opposed to lists, where Python never knows what's going to happen to the lists in terms of memory. It's going to get smaller, it's going to get larger, it's going to get huge, and working with the lists is more it takes up more computing power. So in any program where you have data that's not going to be changed, you're just using that data, it's worth using tuples. If you understand that some data will change during during the duration of the program, then you would use lists or some other mutable data type. So Svetlana, you're saying there are list comprehension methods, so by logic got to be tuples too. Yes, there are tuple comprehension methods. Well, not methods, but there are list comprehensions and there are tuple comprehensions, which are very similar to list comprehensions in terms of syntax. The only difference is that you use parentheses instead of square brackets. So yeah, this is the sorted function. But another thing that I wanted to talk about that the materials do not talk about is the sort method. And this is a list method. And what this means is that it only works with lists, obviously, since it's a list method. So I'll say works only with lists. It changes the list in place, so it does not create anything new. It takes the existing list and changes it. When I say changes, I mean sorts the list in place, and it returns none. So it does not have a return value. What this means is that, for instance, if I take another list, I don't need to take another list. I can take the same list because it hasn't changed at this point in the program. So let me print it once again. This is the old version. Now what I'm going to do, I'm going to say numbers list.sort, and I'm going to print it again. And note the difference. I'm not saving the result anywhere. I'm not saving the result of this sort method into any sort of variable, because it changes the list, since the list is mutable. So if I launch this, you will see that here is the initial list. It's still unsorted. So this is the print in line 42. And here I have the same list that is sorted. And for instance, if I were to do this, what do you think the result would be if I were to launch this program? What would this line say in this specific context? Any guesses?
Shouldn't it still give you the sorted list?
Nope. Let's remember, what does the sort method return?
Oh, none, right?
Yeah, because I see people guessing that it's going to be an error and exception. No, it's not going to be an error. It's not going to be an exception. It will simply print none, because that's what the function returns. So basically what it would do, it would sort the list, and the list would actually get sorted. So you would get a sorted list at that moment in time. But then the method returns none. This none value overwrites whatever was originally in this list. So you lose the sorted list, and instead of that, you get none, which is a valid value. And then when you print it, you get none. So this is very important to remember. This is a very important difference between how sorted works and how sort works, because sorted returns the sorted list. A sort does not return anything. It just changes in place. And some people get this mistake because they forget how these two different like function and method work. And they save the result into a function and then are surprised why the result is none, because that's what the method returns. It doesn't return anything. And in Python, when a method does not return anything, it returns none. Every method, every function returns something, even value none. So this is
This is kind of a stupid question. Okay, none is not the same as an empty list, right?
no, no. None is a special value of a special value data type, which is called none type. So you have none is actually the only value of the none type data type. So Python actually has a separate data type for nothing, and none is not equal to 0. None is not equal, well, if you were to type something like print none equals 0, you will get false. So they are different. If you were to try to turn them into booleans, you would both none and 0 would return false. But these are different. These are different values. So none is not the same as an empty list. None is not the same as an empty string. None is simply that nothingness expressed in a word. So none is, as you would see, none is a special word, much like true and false. You can see that it has this orangey color, which means that it's a reserved keyword in Python. The append method, yeah, Abhinav, you're saying the append method also returns none, which is logical because append changes the list in place and does not return anything. So that's the same reason why it returns none, and why if you try to append something to a list and then save the result of that appendage into a variable, that variable will store none instead of the new list. So this is important to remember as the difference between mutable and unmutable.
Alex,
So,
I have a question too.
shoot.
If I were to sort a list.
Yes. Using what?
Yes, that's my question. When do I choose sort and when would I choose sorted?
With sort, the method, you can only work with lists. So
Right.
if you have a list and you want to sort a list, then your choice would be based on the following. Do you want to keep the original list, the original unsorted list, or not? If you do want to keep it, so you want to have a separate unsorted list and a separate sorted list, then you would use the sorted function, because the sorted function creates a new list, sorts it, and gives it back to you. And now you have two lists. If you do not want to keep two versions, if you just need the sorted one and you don't need the unsorted one, then you use the sort method.
Thank you.
No problem. Any other questions on this? Because these are like the basic theoretical things about sorting. Oh, well, I do want to talk about more about sorting strings, because so far we've only seen how single letters are sorted, but you could actually sort lists. So the question then becomes, for instance, let me do a list of words. And let's say these words are gonna be category, cat, Kellyanne, I don't know. I don't even remember what that word means. Is that like a melon? I don't know, baby, brother. I'm just taking similar names, similar letters. So the question is caviar. Caviar? Oh, sorry. Yeah, I'm mixing
Caviar.
cantaloupe. Thank you, Richard. My English, yeah. I meant cantaloupe, but yeah, but then I want to do something category caterpillar. Let's do it like this, caterpillar. I'm trying words that start with cat. Thank you, Richard. So what would happen? The question is, what would happen if I were to sort this list and print it? By the way, note that I cannot do this because what would happen? What would happen if I were to print this? What would I get?
None.
Yes, exactly, because sort returns none, and I would get none, and that's not what I want to do. So I have to sort it first, and only then I can print the updated list. So how would this list be sorted in your opinion? Which words would go first? Which would go second? How would this work?
It would be sorted alphabetically, right? Because it's all lowercase, and so the B's would come first, and then it would just go. I think character by character.
Right. Okay, so it's quite obvious. I presume that baby would go first and brother would go second. But what about category cat and caterpillar?
I think cat would go first, and then category, and then caterpillar would go last.
Yeah, you're correct. And the reason for this is that after cat, you sort of get the end of the line, and end of the line is like a zero in terms of ASCII numbers. So it goes before any other symbol that exists. So that's why cat would go first, and then you are correct, you would get category because of the G, and then you get caterpillar because of the R. So let's check. Baby, brother, cat, category, caterpillar. So this is how string sorting works in Python, and it's quite useful. But it's important to remember that it's not exactly alphabetical in the sense that you don't only have letters, but you could also have different symbols. So it always depends on the order that they are in the ASCII table. And by the way, if you ever want to know using Python what the ASCII code for a certain character is, you could always use the so-called ORD function. ORD is short for, what's the word? Is it ordinal? Do you call like ordinal? I don't remember.
Ordinal, yes.
Ordinal, like first, second, third, those are like ordinal, right? Is that what they're called? Well, never mind. So for instance, if I would go, let's take a look like at space, it only takes in a single character. It will never evaluate a full string. It has to be a one character string. So let's take the exclamation mark, let's take the capital A, let's take the small a, and for fun's sake, let's take a Russian A, which is very difficult to see the difference because there is none in terms that they're printed, but you will see that there is actually difference because space has 32, exclamation mark actually has 33, the capital A is at 65, the small a it's 97, and the Russian A it's at 1072. So they would be sorted in this order if you had a list of strings starting with these specific characters. So this is like 32, this is like 33, this is 60, 65. If we were to have a number, the number would be somewhere in the 50s range. So for instance, here, if we were to type like the ordinal of, for instance, 0, you would get like 48. I don't remember them exactly, but like I said, they go before the letters. Svetlana, weird, silly question. There are no weird and silly questions. Come on, guys and girls. I mean, ask any questions that you have. I mean, this is the way you learn. Do language model transformers use sorting kind of methods and tokenizing? To be honest, I do not understand half of the words you're using here. I have no idea what a language model transformer is. I do not know what tokenizing is. So that is not a weird, silly question. That is a question I cannot answer. So it must be a smart question. What if we have cat and cat? Well, there is a good question. What happens if you have capital cat and small cat? That's a good question, and let's add a capital cat in here. What do you think would happen? Oh, actually, yeah, I see the answer. Yeah, Min already wrote that the capital cat would go first for this reason, that the capital letter has a lower ASCII number than the small letter, but let's check whether that's the case. And you can see that cat actually goes before all the other words, not only before this cat, but before all the words. So if we were to have zebra in here, it would still go before the small cat because the capital Z has a smaller ASCII code than the, whatever small letter you have in here as well. But that's a good question. You could use lower first if you wanted to check, strings with different sized letters, different register letters, and compare them to one another. Okay, so I think in terms of theory, these are the things I wanted to walk through before we could go to the specific assignments which we had. And if I remember correctly, we didn't have that many assignments. Where did they go? Did I close them? I think I closed them by mistake.
Can you talk about Lambda?
I will talk about Lambda, but I will talk about Lambda in the context of the assignments that we're going to do. It's going to be
Okay.
more practical that way. Because talking about Lambda in theory is just, your eyes are going to glaze over. So give me a second to pull up the assignment links. Okay, there we go. Okay, so I would actually look and maybe go through these tasks in order, even despite maybe you solving them, to make sure, because there are different ways of how this can be done, and it will not take us a lot of time. So let's go through them one by one, and I will talk about Lambda here as well. So the first one that we have a list of numbers that is unsorted, and we need to sort it based on its absolute value. So let's copy this. I will comment all of this out so it does not bother us. So here's the list that we have. Let's call it numbers. And like the basic sorting algorithm for it would be numbers.sort. That's one way to sort them. Or the second one would be numbers equals sorted numbers. So in our case, these two lines would do the same. Pick one that you like more. It doesn't really matter in terms of the end result. Maybe the first one would be a bit faster, but I'm not sure. So let's stick with the one that we had in the materials. So sorted numbers, which would only give us, I have to print it. Would simply give us the sorted list. So yeah. But in our assignment, we're asked to sort it according to its absolute value. So how can we do that? The sorted function, as the sort method as well, and this way they're very similar, has a keyword argument which is called key. And what key does, it allows you to pass over a function which would be the criterion for the sorting. So in our case, for instance, we have a function which is called abs. The function abs, which is short for absolute, returns the absolute value of its parameter. And what this does is that the sorting algorithm, instead of just going from, lowest number to highest number, it looks at the result of this function's call for each specific number. So it would look at the result of, applying f's to the number 3, then to the number 2, then to the number -1, and it would sort based on the result of that function and not on the specific value that we have here. So instead of sorting it like 3, 2, -1, it would sort it like 3, 2, 1, 7, 7, 5, 14. Then the question would become what happens if you have two values which have the same absolute value. And in this case, they would go in, I believe they would go in the same order that they are in the list initially, but let's check whether that's the case. Yes, that's the case. So as you can see, we have 1, 2, 3, 4, then we have two 7s in exactly the same order that they were in the unordered list. And at the end, we have 14. Pay attention, this is important. Then when you pass a function to the key parameter, you do not include the parentheses. Because if you include the parentheses, that's actually calling the function. You would call a function instead of passing it as a parameter. So this is important. If you want to pass a function as a parameter to another function, you do not include the parentheses. You do not need to make a function call. You're just saying, use the function which is called this way. So it's like the function itself is a variable that you're sending to the other function to do something with it. Can we also cover data structures, linked lists, binary trees, graphs? Well, we're not certainly going to cover this today because this is a separate topic, and I don't think this is something that that's in the Stanford curriculum, for the simple reason that these things are a lot more complicated, especially if you start talking about graphs. People need to be like theoretically prepared for that because before we actually discuss it in programming. It's useless to discuss it in programming if you don't have any idea what a graph is, for instance, outside of programming. So yeah, for now, let's pass on that. So this is the way that the first assignment is done. You function to the keyword in order for the list to be sorted according to the return value of this function. And if at any moment you have questions, guys and girls, just give me a shout out. If you don't understand something that I'm explaining, either write into the chat or do voice. With voice, it's going to be quicker because I can hear you immediately. With the chat, I glance into the chat from time to time.
I have a question.
Sure.
So in line 59, you use the key and use a Python function such as abs.
Yes.
You can always, if there's a defined Python function, you can always use that. You don't need to create your own function that returns, for instance, a Python function. You just use you can pass in the key directly.
Yes, if you have a function that already does what you so a function, if you already have a function which produces the criterion by which you want to sort, then you do not need to write your own function. You can already use the existing function. But sometimes you're in a situation when there is no such function. And we'll come to that in the next example, I think, when you have, the absolute value of their difference with pi. This is a very specific request, and obviously there is no such function in Python, which would actually return to you the absolute value of the difference of the parameter with pi. I mean, that's a very weird request. I'm sure you agree.
Yeah.
So in
I
this
bec
case,
Yeah,
yeah,
I was wondering if, for instance, if I were to sort by length, I didn't know I could use the key equals, for instance, len. I
but
thought I would have to write my own function that would return the length of for instance, as of a string,
if
if
it's a
it were
string, then you can return length. If it's numbers, you cannot use length
yeah,
because the numbers don't have a length.
yeah, right.
But yes, you can sort by length in ascending or descending by just simply doing this. So let me prove it to you. Let's take words again, and we'll have a list of words, which is I don't know, B, C, DG, not exactly the words, but I guess you can guess, and then an empty string, for instance. And then I would do like words. Let's do a sort. Just use different ways. I would do the sort method here, and I would say key equals len, and then print the result. And you would see that they are listed now sorted by length. So we have length 0, length 1, length 2, length 3, length 6, and length whatever, 10. And you can do reverse here as well. If you do reverse equals true, you would get them in reverse sorting order. So let me quickly go through the chat. Perhaps Alex needs a Patreon. This is not the first time I actually heard that. Did the meeting start early? Yes, Nate, we did start an hour ago.
Oh,
We've just started talking about the specific assignments because I spent quite some time talking about theory and the difference between the sorted function and the sort list method, which is not covered in the Stanford materials for whatever reason. So if you are familiar with the sort list method, you did not miss much. If not, then I would urge you to sort of watch it in the recording, because there are some important differences, and it's important to note both the sorted function and the sort list method.
Alex, could I ask you a quick question?
Of course.
First of all, I screwed up with the time, my fault, and I'll go back and listen to the recording. But in the
Sure.
recording, did you cover the following question? I got confused by the syntax that we've understood for sending parameters to a helper function, okay? With the understanding, in my mind at least, that you had to be careful about, or you had to pay attention to how many parameters you were sending to the helper function, and that the helper function had to have those same number of parameters, correct?
Yes.
But with the sorted function applied to a list with a key, and then using a helper function to set the key, to define the key, okay, somehow the list itself gets sent as a parameter to the helper function, okay, but how does that happen? And the key seems like it's another parameter, but it doesn't go to the helper function. How does all of that work? Is that something you described?
No, but I'm more than happy to talk about this right now. So when you actually pass a function into the sorted function or into the sort method, which basically work the same way in this sense, you are saying that the list is sent as a parameter. That is not correct. Each value of the list is sent as a parameter to this function one by one. So it's not the entire list that goes in there. The function is called over and over again, and it's applied to each value in the list. But the function actually gets only one value. And the thing is that usually in this case, you would need a function which takes only one parameter for it to work as a sorting criterion. And key is simply a named parameter of the sorted function, which means this is the function which I want to use for the sorting. Am I making sense?
Well, I do understand the one-by-one thing that you described. Okay.
Yeah.
But the way I set up these problems was I set up a main function that called a helper function.
Yeah.
So whether it was absolute value or the difference with pi or whatever it was, I called it in a main function and then set up a helper function. And there's only one parameter in the helper function, okay? And it knows somehow that it's the list that was used in the main function where I used this, where in the sorted method in the parentheses, okay, I had the name of the list, and it knows to use that list, okay? But in the sorted function, it's got not only the list, but it's also got the key. But for the
It could also have something else. It could have like reverse equals true. That would also be
right.
another parameter. Yeah.
Um,
I don't understand the confusion. So let me talk through this once again. So the sorted function, the requirement for the sorted function is to have at least one parameter. So it has to have some sort of sequence that is going to be sorted. So for instance, in this case, it takes this list as a sequence, but as we talked previously, it can actually take in a tuple, it can even take in a dictionary, because inside the function, it actually creates a new list. So the old sequence remains unchanged, you get a new list, which is going to be sorted and returned from the function. So the result is always a list, regardless of what the input was, what type of data the input was. Mm-hmm. And if you do this, it knows by default that you have to simply sort in ascending order. If it's numbers, you get ascending numbers. If it's strings, you get, alphanumerical sorting, like what's it called? Lexicographical in English, I think. Like in alphabetic order, basically.
Right.
In ASCII table order.
Mm-hmm.
But the sorted function has a number of named parameters which allow you to change the way that the sorting takes place. So you can say, I don't want ascending, I want descending. And in this case, you do this. And the sorted function knows that if the reverse parameter is true, it needs to do it differently. And it also has the key parameter. What it does, it tells the sorted function which other function you want to use in order to generate return values, which will be the criterion for sorting the values in the list. So basically, instead of sorting by these values, which the function does by default, it sorts by the return value when each of these values is passed into the function that we have here. So instead of
there, Alex, it's right there that my confusion is, because the key equals ABS, right? Absolute. So somewhere you have to define, I didn't see where it was, you have to define what absolute is. And I assume there's a helper function someplace.
But this is an existing function in Python.
Oh, I see. Okay. But if it wasn't an existing function,
and you have to define it.
And if it was defined in a helper function, okay, then somehow when I did these problems, which maybe we can go into when we do the problems, the helper function knew that the numbers list existed. Like I could, in the parameter for the helper function, I could say list, but it knows when I'm calling it in this way that it's the numbers list. Okay.
Right. And your question is, how does it know?
How does it know? Okay.
And that's the way the sorted function works. That's how it knows.
Okay.
You do not have to understand how it works in terms for users. The sorted function is like a black box. It has input, it has output, but you have no idea, what goes on inside. It's much like you drive a
Yeah.
car, but if you were to ask me, like, Alex, why does a car, go vroom vroom? And I would be unable to give you all the specifics because I'm not a car mechanic. And it's the same here. It's like the magic of the sorted function. We could actually open it and look inside and spend some time, figuring out how it works. And it probably, my guess would be that it actually iterates over the list of numbers. And then one by one, it sends those numbers into the function that you highlighted here, gets the return values, puts them in a separate list, sorts that list, and then sorts the initial list itself according to the same indices. That would be my guess. But I've never looked inside the sorted functions because I never had the need to understand how it works, because it just works, and I'm sort of happy that it does.
Okay, so let me try to see if I understand now. So let's say the key was not a given function like absolute, but it needed a helper function. Okay.
Yes.
And so,
We'll look at some examples of that later.
okay. But what I think you're saying is, don't worry your little head about it, Nate. Okay. There's something special about the sorted function so that the helper function knows not only, okay, what you want to, what you wanted to compute to return to sort by, but it also knows the list that you're using in the sorted function. It knows both somehow.
It does not know the list. The apps function does not care about the list. The apps function will only get the values from that list one by one. It will never see the list itself. This is the work of the sorted function. The sorted function knows the list, and it sort of goes like, hey, apps, here's the number 3. What's the absolute? It gets back 3 in return. Hey, apps, I have -7. What's the result? It's 7. Okay, give it back to me. And it sort of passes it back and forth one by one with the apps function. The apps function never sees the list itself. It only gets the integers one by one.
That I understand. And this is my last attempt, and then I'll wait for the actual problems.
Sure.
But how does the helper function know? Like when I write the helper function, I can name the parameter whatever I want to, okay?
Sure.
In order to do the function that I want the key to be under, okay? But it knows that it's the list that's in the sorted function. How does it know that?
Because the sorted function
Yeah.
calls that specific function and
Okay.
passes the
All right.
parameter into that function. So it's a function call inside another function.
All right. So it's different than other things where whenever I would call a function in main, the number of parameters would be exactly the number of parameters that I saw in the helper function. But in this
Yes.
case, because it's the sorted function, under the hood, it does all that, correct?
Yes. It
Oh,
simply passes one parameter into that function and gets the return value back.
okay.
So yeah, we'll take a look at it in more details when we actually come to. I think that was the next assignment we wanted to do, to actually get to write a function which we will then use as the key for the sorting.
Okay, thanks.
So I say let's try doing that. So in this specific one we had, I think it's the same list. So let's just copy in again. So same list, but now we have to sort it by its absolute distance from pi. And obviously there is no such function because it's a very strange and specific request. Why would you need to know the distance from pi? But who are we, to ask? Let's just do it.
Circular reasoning, that's why.
Sorry?
Circular reasoning. You need pi for circular reasoning.
The difference between a number and pi.
I'm just pulling your leg there. Sorry.
Oh, okay. I don't know. Maybe it's used somewhere. I'm not a mathematician, so So we need to do. Obviously, we need to sort the same list. But then the question becomes like, what do we put here? There is no function which does this, and then we go like, okay, but we can write this function. So let's do that. Let's call a function which will be like abs dist from pi, which would stand for absolute distance from pi. And this function will get an integer, or, well, yeah, it's an integer. It doesn't matter. It could be a float as well. Let's call it, I don't know, number. It doesn't matter. We could call it X. We could call it whatever. So if we need to calculate how far away that number is from pi, whether it's a positive difference or a negative difference, we don't care. We need the absolute value. How do we calculate it inside this function?
You would just subtract, right? Like either the number from pi or pi from the number, and then use the absolute value function.
Exactly. We don't care about the order because we're going to get the absolute result. So we'll take something like number minus pi, which is 3.14. Then we would apply absolute to this result, and we would need this function to return this result, right? So we calculate it and then return the result of our calculation. And now we can actually use this function that we just wrote as the key. We're going to write, see, it immediately shows up here, but one more time without the parentheses. Because we're passing the function name, we're not doing a function call here. We're just saying sorted, please use this, a function which is called this, to get the criterion by which you're going to sort the list instead of, regular ascending order. And now, yeah, it wants double lines here. And now if we launch it, yeah, forgot to print it. That's good. And now if you launch it, you will see that obviously the closest one is 3 because it's only 0.14 away. Then you have 2 at 1.14. Then you have 5 at 1.86. Then you have 7 at 3.86. Then you have minus 1 at 4.14. Minus 7 at like 10.14, and actual 14 that you have at like what, 10.86. So it's actually sorting by the result of running each of these values one by one through this function, getting the result and using that result as the criterion for the sorting. So does this make sense? Does anyone have questions at this point? And Richard, I saw your message about the one-liner. We will talk about this a bit later when we talk about lambda functions, because I promised to talk about lambda functions. But first,
Well,
it's important.
I think that kind of helps me, and it gives me a good chance to like really be specific about how I got confused. So
Sure.
In your helper function, you have the parameter number, which is not numbers, okay? And
Right.
the main
I could
function,
call it anything. I could call it X.
that's correct. You could call it anything, and because the sorted function lists numbers as part of what it lists, that gets passed to the helper function, and that's how number knows that it's going to use numbers, correct?
Yes.
Okay.
So
However, the thing that confused me was in doing what we've done in the past, whenever there was a call to a helper function with parameters, in the parentheses, I'm used to having parameter 1, comma, parameter 2, comma, parameter 3, comma, and in the helper function, there need to be that many parameters. But here in the sorted function, it's numbers, which is passed, and then a key, which is not passed. And that's where I think I got confused in terms of the syntax.
But these parameters are passed into the sorted function. They're not passed into the helper function.
Well, but the helper function knows that numbers is what it needs to apply the absolute value to.
Yes, because inside the sorted function, somewhere it says iterate over numbers. So it goes into a for loop, I presume. It goes for value in numbers, call this function, pass that value into this function, get the result, and use that result as the criterion for sorting these values. So the sorting now happens not by these values, but by the results which this function gives back to sorted, and sorted sort of goes, okay, this is actually not 3, this is actually 0.14. This is not 2, this is 1.14. This is not -1, this is 4.14, etc., etc. And it sorts by those values, but keeping the original values in the list itself.
Yeah, all of that I understand, and this will be my last try, but how does X know that it's going to do the absolute value of X minus 3.14? How does X know that it's numbers? In the
It does not. It doesn't care whether it's numbers or not. So let me try.
Each element in the list.
I see. Okay.
Because let me try. So for instance, let's say we were to write the sorted function. Let's say the sorted function did not exist.
Yeah, I think I just got it. Okay.
Yeah, because here you would have sequence and you would have like function, like key function name. And then you go for value in sequence, pass it into the function. So you'd have the function name, you would pass the value here, you'd get the result back, and then somewhere here you use the result to sort the sequence.
Right.
Does that make sense?
It does make sense, yeah.
Okay, cool. Any other questions on how this works before we get into some more interesting stuff? Let's see what the next one is. Given a list of strings, sort the list case insensitively. Okay, let's do that. So in the next one, we have to sort a list of words, a list of strings. Let's do sorted again. If we were to do it like this, as we already saw, they would be sorted lexicographically, and we remember that the capital letters go before the small letters. So you would get first CS106A, you would get Katie, you would get Maran, only then you would get Juliet and Python. But let's make sure that's really the case. I'm not lying. So now the question is, how do we do this? How do we change this so that the actually disregards the sorting algorithm, disregards the case? So it would actually go CS106A, then Juliet, then Katie, then Maran, then Python. So Juliet would have to go somewhere here because it goes in front of Kate. And in this case, we would need to use the lower method as the key. And here my memory fails me a bit, so let me try. I think it would have to be like this, but I might be wrong because, yeah, this is the second time I'm getting the... Oh no, it actually works. Why is it underlining this? What's the thing that it doesn't like? I don't know. So basically, as you can see now, it applies the lower method to each string before it sorts the strings. And it does not actually change the strings themselves. Juliet is, CS, for instance, still is capital letters, Katie capital letters, Maran capital letters, etc. But the criterion by which the sorting is done is actually as if this was capitalized and not capitalized the other way around, lower. Like this was a lower letter and this was a lower letter and this was a lower letter. So it takes that into account. The reason why it's written like this is that since lower is a method of the string data type, you can't write it like this because there is no lower function. There is no such function. You actually have to tell Python which data type it belongs to. Usually, instead of str, we write the name of the string. But here we don't have a specific name of the string. We just have the data type. So we pass the method of a specific data type and not like a general data type and not a specific string. Like, once again, I don't understand why it's saying inspection incorrect type option. I have no understand why it's underlining it, what it thinks the error here is. But I mean, it works. It gives the result as expected. So yeah, let's just ignore it.
Alex,
Yeah.
okay, so just a comment, for that question, I don't think it really matters which case you change it to. You could change it to I guess, all uppercase, and then
Upper.
it
It
would
would
still
give you
work.
the same result exactly. Yes. It's just that it's, yeah, it says case insensitively. For some reason, I thought that it says the lowercase. It doesn't matter which case. You are absolutely correct, because, in terms of letter size, it doesn't matter. If there were some symbols which are between, like the capital letters and the small letters, it would matter. But since here we know that it's words without other symbols, yeah, it could be both lower, upper, or whatever. That is absolutely true. And Mika, I see your question as well. Yes, the answer is yes. It would sort the same way as we can see. So the next one says we have a list of tuples which represent addresses in the form of street name, city, state, zip code, and we need to sort based on the numeric value of the zip code. So let's create maybe a quick addresses. Okay, addresses. So it's a list. It's a list of tuples. So let's do 3 tuples. And each tuple is street number. What's the street number? Then street name, I would guess. Like street, city, state, zip code. Okay, let's call it like, I don't know, straight avenue. It would be San Francisco. Does San Francisco have a straight avenue? San Francisco CA, and the index would be, I have no idea what the like the postal codes in California are, so I just go 1, 2, 3, 4, 5. Then the second one we would have something like Crooked Street. Crooked Street would be somewhere in,
That's called Lombard Street. We actually do have a crooked street. It's called Lombard Street.
so, and here it would be 10965, for instance, and the last one will be it will be Russian highway. Why not? I mean, why not? This will be, of course, in the lovely state of New Jersey. Sorry, the city of New York, and the state for that would be New Jersey. Am I correct? With this zip code. And now we want to sort this. We want to sort this according to the postal code. So the way we would be able to do it is the following. So if we were to use the sort method, we would need to list as the key some sort of function which takes this into account. So which returns, we need a function which actually returns the postal code so that the sort method can sort by that code. We don't have such a function, so let's write it. It's going to be get postal code from some sort of address. And the way we do it, we simply take a look. What index is the postal code at in this tuple? What's the index number?
3
Exactly.
-1.
You could actually do -1. That's actually an interesting way to do it, because you could use 3, or you could use -1. In our specific case, it would give the same result, but let's do -1. I like it. Like the last one, we know that in each line it's the last one. It's always, the last one is always the postal code. So we return the postal code, and now as key, we use get postal code. And let me change this a bit so it's more interesting to sort it like this. and it gives us an error. Why? Because this, I did not, by mistake, yeah, I forgot to delete the parentheses. So one more time, and of course we need to print it. Print addresses. So here, as you can see, the first one that we have now in our new list is the tuple for 10965. Then we have 13526. Then we have 72345. So now the addresses are sorted by the postal code, because the function that we use as the criteria for the sorting returns the last value from the tuple, which is the postal code. So is this becoming sort of clearer how this stuff works, and what the advantage of using this key parameter is? Because it's, I mean, if you plan to use sorting functions somewhere, this will help you immensely.
So Alex, a question about this problem. It's another little nit about syntax. The question is that the addresses is a list of tuples. Right?
Yes.
However, when you go to the helper function, okay, and you return address, and again, it knows what addresses is somehow, or maybe not, maybe it's just address -1, whatever that is, from what you were saying before. You're using the index -1. How does it know that the index -1 is applied to each one of the tuples rather than -1 applied to the list itself? Because -1 in the list
Yeah, I
itself.
understand your question.
Yeah, okay.
Okay, so how many values does the list addresses have?
1, 2, 3. It's got 3 tuples.
Okay, it has 3 tuples, exactly. And remember we wrote out the sorted function, sort of, imagine writing it out. So what the sorted function would do, it would iterate over the values which are stored in the addresses list. So the first value would be the first tuple, the second one would be the second tuple, the third one would be the third tuple. And one by one, it would send those values into the guest postal code helper function. So by this reasoning, we know that this address, which we can once again call X or whatever we want to, not be confused, X would get tuples. And this get postal code function does not care about this list. It has no idea even that this list exists. It only knows that first it will get this tuple, then it will get this tuple, then it will get this tuple.
Okay, I think I get it now. Because the sort function itself does the iterating, and
Yes.
so that's how it knows that it's going tuple by tuple, that it's sorting tuple by tuple, and that clears up my confusion.
Yes, exactly.
Okay, thanks.
Okay, so Richard, I saw your proposal that, it's easier to use lower rather than upper, because probably in most texts that you have more letters starting with lower than with upper. I do not think that it would actually matter much for the speed of the sorting algorithm, because you would still need to, make all the words go through those functions. But yeah, I think it wouldn't really matter. Both would work. Susanna, you're asking, is there a way to sort by local alphabet because you have specific characters which need to be in specific places in your alphabet instead, like between a C and a D or somewhere. And I think in that specific case, I'm not sure. For instance, if you talk, my guess would be you're talking about the Czech alphabet. And I do not know whether the Czech alphabet has an entirely different alphabet, like from A to Z with all the extra characters listed in a different place in the ASCII table, or you only have the special characters listed separately. Because in first case, it would sort the same way. In the second case, you would actually, this is my guess, I've never sorted Czech alphabet before. In my feeling is that you would actually have to write a special function in which you would create a dictionary where you would like have your letters of your alphabet, for instance, as keys, and you could have their order as values, or the other way around. And then you would use that function so that it would return the value for each specific letter. This is my guess. Like I said, this is probably the way I would do it, but maybe I'm just not aware of this. There are already functions which help with that, but that's my guess. Add a print x line in function to demonstrate. Well, yeah, I think we figured it out. So yeah, works. Doesn't matter for speed, just more comfortable conceptualizing lowercase as normal. Yeah, I mean, for me, it's also for some reason easier to go lower than go upper, but it's, you know, a very personal thing. Someone prefers upper, and there is nothing wrong with that. It's, you know, whatever you want, however you want to do it. I hear some music coming from someone. Can you guys check your mics so that it's like someone is playing the guitar, like listening to Alex playing the guitar sounds nice. I think it's Tracy. Tracy, we can hear the guitar coming from your mic.
I apologize for that.
No problem. Very nice. But yeah. So this is how we would do the postal code one. And what else do we have? Like list of tuples, the same addresses by the absolute value of the difference of the zip code and Stanford's zip code. I don't think we need to do this because this is actually a mixture of what we done previously. Basically, we would get, instead of get postal code, we would write a function which would say get difference with Stanford. And here, instead of returning x minus 1, we would return like Stanford's code minus x minus 1, the absolute value. And there I've done it, I think. So now we see that this one is the closest to Stanford for obvious reasons, because the difference is the smallest. Then the second one, then the third one. If we were actually to add Stanford someone in here, we would go like Stanford square. Does Stanford have a square? Is there a Stanford square?
Well, there is no such thing as Stanford Square. There's Stanford Circle.
Okay, Stanford Circle. Okay, why not? I mean, Stanford
There's
Circle.
Palm Drive.
No, this works for me, like this. Let's change it a bit. Let's change it to 94303, for instance, somewhere. And we would see that this one is the closest. So logical. And here we have a file. So this sort of mixes it up with reading information from a file, but that's sort of a different topic that we discussed last time. We could get information from a file. That's not a problem. Like we have name, ID number, email, graduation year, and number of units, whatever that means. I don't think this is actually about sorting. I don't think this is about sorting. I think this is about reading files. Is it? Yeah, I think so. And then the next one, sort of, when we have this function, we need to write a function that sorts these tuples, but by their expected grad year in descending order. So in order to do that, once you have a tuple that has this information, so let me just do this quickly. For instance, we have students, a list of students, and we have Juliet here, and then we have someone else, and then we have someone else. We have Juliet's evil twin sisters. We have Juliet Woodrow, we have Agnes Woodrow, and we have just evil twin Woodrow. And let's say that this one is like this ID, this is like this ID. We don't have like A Woodrow, we have ET Woodrow. And this one is supposed to graduate here. This one is supposed to graduate here. We don't have to care what these numbers are. And now we need to sort in descending order by this here, if I'm not mistaken. By their expected grad year. Yeah. Hold on one sec. Yeah. So in this case, once again, we can do the students sort using something by the key. So it's a question, and we would need to do the reverse equals true to get the descending order. So we're going to send two named parameters into this method and then print it to see the result. So the question is, what's the function? What would the function be? So let's call it get grad year for some student. So now my question is, what do we need to write here in order to get to sort by this? Obviously, we need to return something. What do we need to return? Any ideas?
You return index 3.
Okay, so we could do student index 3 because this is 0, 1, 2, 3, or we could do index -2 like we did in the previous one. Doesn't really matter. And here, if we do get grad year without the parentheses, of course, we would see that we first have evil twin Woodrow at 24, then we have 22, and then we have 21. So in descending order as we wish to do it. So coming back, Nate, to your question, then the problem we just skipped. I don't think we just. You mean skipped in the sense of reading stuff from a file? Let me go through it. I thought there might be an error in it. The problem wants an output that is a tuple, but doesn't the readlines function output an actual list to a tuple, but that is not shown. Let me take a look one more time. Reads in a file and returns the tuple. So, but I mean, if we're writing a function, are you saying that this is not shown in the solution? Because I haven't seen the solution. So we open the file, read the lines.
It doesn't show that way in the solution.
It does actually,
Really?
because here's what happens. You read the student info list from the read lines, but then you actually save the values from this list into separate variables. So we have like 1, 2, 3, 4, 5, and then here you return a tuple.
Oh.
The parentheses are actually not necessary. This is like explicit, but it's not necessary for the simple reason that if you remove the parentheses, you would still the function would still return a tuple because that's what it does by default. It cannot return 5 values. It has always to return one value. So does that make it clear?
Oh yeah. That does. But the read lines function does in fact create a list, but then later on, I now understand that tuples were created.
Yes, not tuples, but a single tuple.
Single tuple.
Yeah. So it was just filled with these variables, these elements. Aim this function reads the list and makes a tuple. Sorry, Richard, you lost me here. Oh, the aim of the aim is to read the list and then make a tuple. Yeah, so that's exactly what it does. True. So we have about 15 minutes remaining because Vicky has a patient in 15 minutes, and we would have to hard stop at that point. And the thing that I wanted to talk about here.
Well, clarification. Okay, I did email the person. I told the person I might be late. And so if anybody comes into the waiting room, just don't let them in, okay? I'll give you until like 2:15, but I can't like,
Sure.
have
Sure,
this.
but still, like I said, in my mind, patients are more important than tuples, so I would prefer to end on time. So the thing that I wanted to talk about right now, due to popular demand, is lambda functions. Because what we're doing right now is each time we want to sort something using, some sort of criterion, we actually have to write out a separate function and then use that function. And the question becomes, is there a way to make this simpler? Maybe there is no need to actually create a separate function each time we want to do this. So yes, we will talk about lambda functions, which are very hard to understand in theory, because then the question becomes, why do we need them? But once you get into practical mode, you sort of start understanding what the implications are. So let's once again take one of the problems that we had. For instance, let's take the one with the addresses. And which one? Okay, let's do this one. Like, how far away is it from Stanford? And I'll copy this. I'll put it here once again. So once again, we have the addresses here unsorted by how far away they are from Stanford. The question then becomes, if we do not have this function, can we actually create a function here in line instead of spending time to create that function separately, if we understand that we're not going to use that function anywhere else? Like, this is a one-time thing. We just want to create a throwaway function which will work right here, right now, and then we don't need it. We don't actually want it to be stored in memory and take up, space in memory, because we know that we're not going to use it again. And the answer, of course, is yes. This is where lambda functions come in. A lambda function, I have no idea why it's called a lambda function. I think this comes from mathematics, but I have no clue, and it's not important. So what it allows you to do is actually write out a function definition right here inside this line. So we are going to define a function. This function will not have any name because we don't care about its name. We know that we need to use it here. And for some reason in Python and other languages, this is called lambda. Don't ask me why. It could have as well be called, nameless. And this would have made more sense for me, or, unnamed, whatever. But for some reason, it's called lambda. The way it works is that we, after we write lambda, we write a parameter name. It could be any parameter name. In our case, it was X. It could be like postal code. It could be whatever. But let's stick with X. So X is the parameter which is going to be passed by sort into this function. So this will be its first parameter. This will be its second parameter. This will be its third parameter, etc., etc. So we could have called it address, for instance. Is this the person I'm not supposed to let into the room, Vicky? Because I see right now a person in the waiting room, and it looks very much like a person I would not want to admit right now. If you're answering me something, I'm not hearing you. Maybe you're not hearing me.
Sorry, I was on mute. Just ignore this, okay? I will
Okay.
text the person. Okay.
Okay, I see Richard put in an explanation in the chat why they're called lambda functions, so you can read it at your leisure. But since I don't have much time, I'm going to focus on the explanation right now. So we have a parameter which is called, in our case, address, because this is what we're passing into one by one, the addresses. And after the parameter, you put a colon, much like you would do in any regular function definition. So for now, the difference is that instead of def, we say lambda. And after the colon, you can write one line what the function is supposed to return. And in our case, the function is supposed to return the following. We are supposed to return this code minus whatever we have at the last index of the tuple, the postal code of our location, and then return the absolute value. And this is functionally the same as this. There is no difference between doing it this way and doing it this way in terms of functionality. The difference is that, first of all, you do not have to define a separate function which will take up space in your memory, and it's sort of longer to write than a simple lambda function which you can fit into one line. And this function will be discarded by Python as soon as this line ends. So once again, the syntax for using lambda function is the following. You go lambda, then you say parameter name, then you have the colon, and then you have some return value, which obviously that uses the parameter. Because if it didn't use the parameter, then why are you doing this in the first place? It would be weird. So this is the syntax for the for lambda. And as you can see, it makes life a bit easier. And once you get used to it, it's actually quite easy to read. And you don't have to have a bunch of functions which you're not actually planning to use. But let's run this and actually see that the result that we get here and the result that we had before, they are the same. They are exactly the same. There is no difference between this one and this one. It's shorter. It's more concise. It's looking nice. So is this clear? Do you understand how this works? Does this seem logical? Because if there are any questions, please give me a shout out. We still have time. I'll answer.
I've got a couple questions.
Right.
Sorry. I was a little bit distracted. So for the lambda, right? Like it can only take one expression, right?
It could only take one parameter.
Okay.
Although you could of course like send in like a tuple. So here we're sending a tuple. So basically we're sending in like 4 values, but for the case of being a parameter, it's only one value.
Well, so here, what are you sending in as the parameter? What's the address? Is it each of the tuple?
Yes. So each tuple in order is sent in as an address the same way it was sent here. Here we called it X.
Okay.
Here it's called address, but we could easily substitute this like this.
Okay. And so when you send it in to Lambda, right? Okay. It knows you're talking about zip code based on the indices, right?
Because of this.
Right. Okay. Okay. Suppose like you have a list. Suppose you want to first sort based on the zip code, and then you want to sort based on state. Okay. Within that addresses sort, can you have 2 different lambdas?
I do not believe so, no. I
Okay.
might be wrong, but I don't think so. I don't think you can have multiple keys for sorting.
Okay. But if you were to use the other method, which is like writing a subfunction, is it possible to kind of write within the subfunction like sort first by say zip code and then sort?
I understand your question. Once again, I could be mistaken, but the problem is that your subfunction still returns on only one value. The subfunction does not sort anything itself. It simply gives you back a value using which the sorted function or the sort method actually performs the sorting. So it still only gets one thing that it uses. And I'm thinking right now, if you were to return maybe a tuple, you could probably try returning
Well,
like several.
do you see there's any reason if you're using a subfunction why it cannot return more than one value? Because I think for a subfunction, you could return more than one value.
Let's try doing this. Let's try. So for instance, I could maybe here if let's see if
Well,
this works.
I feel like conceptually, okay, conceptually, I know if I could just write like a sequential function to do two sorts. You know, you could take the output of one sort, feed it into another function. I'm just asking for the sake of argument, you know, whether it would be possible to kind of combine the
So
two.
let's take a look. It seems that right now, so we have two addresses with the same index. So the first one is 9, the last one is 1 because it's descending order, and we have 2 here in the middle. And inside these, they are at the moment sorted. Oh, that's not the one I need to look at. I need to look at this one. We still have first California. Why is it? No, here, we need to look here. It's first California and then it's Ohio. So no, I don't think it works. And because here it's still in ascending order, it's not descending order. Like, oh, hold on, but it's supposed to be ascending, or we're not doing this by descending. No, that's my mistake. Let's try changing them and seeing whether this actually works. So now this is going to be Ohio, this is going to be Cleveland, and let's try running it once again. And now, yeah, it looks like it works. So we first always get California, and then we always get Ohio, regardless of everything else. So you can see here we get first Crooked Street and then Straight Avenue. And if we change it back to what it was before, we would first get Straight Avenue and then Crooked Street. So here what I did, so you can do this with Lambda. I've just never done it, so I was sort of like, whoa, how do we do this? But here I'm returning a tuple of two values, and the first value is the distance from the Stanford code. And in case it's the same, we have the second value, which is used for sorting, which is the state.
That is pretty cool.
You see, I learn something new every day as well. This is nice. This is nice.
I know.
Any other questions, ladies and gentlemen? Because I know we also had, like, we looked through all of these assignments. We also had one assignment which was called sorting houses, which is basically we have a list of tuples which have the address, the number of bedrooms, and the price, and we need to sort it using various criteria. And then the first one, we need to sort by number of rooms in ascending order. So we could use a lambda function here to take index 1, sort by index 1, and you would get them sorted by number of rooms. So nothing especially difficult here. And the second one, if we need to sort in descending order of price, we would do it by index 2 or by index -1, whatever is your preference, and write reverse equals true, then it would sort in descending order by price. And price per room, you would actually have to write a lambda function which would take index -1 divided by index -2, return the result, which would give you a price by room. So here you'd have 4,000 divided by 4, it's 1,000. Here it's going to be 1,200. Here it's going to be 800, and it would sort by that. So if you haven't done this, this is this is something you could try yourself. Now that we went through all the explanations, you'd need another function that does the two sorts. Alex should be paying us, right? Right. We all can be the spawn of millionaires. I wish we were, but we're not. So yeah. So if there are no more questions, I would gladly turn this over to Vicky and her patient.
Thanks,
Python
Alex,
works
for
like
blowing
this.
my cover.
What do you mean?
Huh?
What do you mean?
Well, I mean, I basically I basically use an alias every week just to like kind of protect what I do. But it's fine.
Okay, I'm sorry. I did
It's
not realize that went whoosh over my head. Yeah, sorry. Anyway, if that's that, thank you guys and girls for attending today. Once again, next week, Nate, be attentive. Next week we're gonna meet at the regular time. So the usual time, which is noon. Is that correct, Vicky? Like noon your
Yes,
time,
it's
noon
noon
Pacific.
for a very, very special guest. And
Yes,
then
it's
I'm
not gonna
actually a
be.
big fan of this person because yeah.
Hold on, we already know who the person is.
Huh?
We already know who the person is.
Who is it?
Oh, I thought you said it was Cameron.
Oh no, I
Oh
never
no,
said it
then
was Cameron.
I did not understand that. I thought you were saying that it was Cameron.
No, 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 no,
Okay,
no, no, no.
my
No.
mistake.
The look-alike person to the
Okay, I thought.
pommel horse guy was Cameron. Okay. This
Okay, okay.
person is like, well, I mean, Cameron is very good, okay, but I think this
But this
person
person
is even better.
very good. Okay, good enough. Some intrigue for next week. And then I will probably attend next week, but like a student. And then in 2 weeks, we'll meet again and talk some more. I think we're planning to talk about nested structures next week.
So,
Yeah,
if I could
in
just
2 weeks.
put in a plug, we only have probably 2, at most 3 sessions with Alex. So if you have any Python questions, please use the forum, pick his brains,
I
and
do answer regularly, so
he does.
sometimes with a delay, but I do answer.
Yes, I mean, it's like mail, it may be late, but he always will answer. And so definitely use this opportunity to get all of your questions answered. And then, if anyone is interested in starting like a Patreon page, or like GoFundMe page,
For Vicky,
no, 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 not for me. For Alex, maybe you guys could get him to like reconsider quitting his other teaching job. I can't speak for him, but
that that would take some effort. But I mean, more interesting things had happened in my life, so you never
well,
know.
well, he also is a big fan of like American football. And so maybe if somebody has like American football connections and then could get like Tom Brady to make like a cameo appearance or something, I mean, would that
Right,
be enough?
to play ball with me.
Mm,
So, like all expense trip from the US to Armenia to play ball with Alex, I would appreciate that. Though actually, I'm not that big of a fan of Tom Brady. I could pick someone more interesting, but
that's
yeah,
sacrilegious. It's Tom
Tom
Brady.
Brady would work as well. He's like okay, like okay.
Well, I think it would be easier to get Tom Brady to go to Armenia than to get you out of Armenia.
That's true. And get me to Tom Brady. Tom Brady would not be happy about that.
Eh, I mean, as long as he could come back, I mean, yeah.
Because
So
he'd be afraid I'd just stay there. Mika, to answer your question, whether I check the forum even after, I probably would. So maybe not like every day, but I don't mind going in and checking it from time to time to see if you have questions. So yeah, that's that. Shall we? Yeah, I think we should. So everyone, have a great day or evening or a good night, and we will see you in a week, and probably, and in 2 weeks I'll be here for sure. So until then, let's just leave Vicky to her work. Bye bye.